Everyone, welcome to Aryan Tutorials. So in this video we're going to discuss how to find the moment of inertia. How to find the moment of inertia of a composite section. So for the composite section we are going to find the moment of inertia. So first we have to know what do you mean by composite section. So composite, always when you consider composite, means it is a combination of different objects. So the composite section is also the combination of different sections, different basic sections like rectangles, triangles, and circles. So by the combination of these different basic shapes, we'll be getting the composite section. So for those composite section, how to find out the moment of inertia? Now I would like to explain. So for that, I want to take a simple example, which is in a shape of L, which is the combination of two rectangles here. So in a shape of L, I would like to take the composite section. So assume this is the L shape, vertical and horizontal parts, two different rectangles here, and we need to find out the moment of inertia of this L shape with respect to certain KK axis. So assume this KK vertical axis, which is at a distance of 100 mm, okay, from the L. Okay, similarly the dimensions for the L are given as, the length of the L is given as 240 mm, okay, and the width of this flange is given as 40 mm, and the remaining height of the L shape is given as 120 mm, and the width of the web here again given as 40 mm. Okay, these are the dimension values are given for the L shape. So now for this L shape we need to find out what is the moment of inertia. Okay, so for finding that, first we need to divide the shape into two or three convenient parts according to the number of basic shapes it is consisting of. So here basically it is consisting two different shapes. So assume this rectangle as one, okay, and this rectangle as second part. Okay, first step is we need to split the shape into two equal parts, two convenient parts. So and we need to find out the moment of inertia of first rectangle with respect to KK axis. Similarly, moment of inertia of the second rectangle with respect to the KK parallel axis we need to find out. So by summing of these two values we'll be getting the moment of inertia of whole composite section. So first we go for figure 1, so which is the first rectangle. So figure 1, consider which is the first rectangle. So for the first rectangle we need to find out the moment of inertia with respect to this axis. So we need to take the help of parallel axis theorem, which states that moment of inertia about the parallel axis is equal to moment of inertia about the center of gravity plus area of that figure into h square, means which is the distance between the parallel axis and the center of gravity of the section we are going to consider. Okay, so this parallel axis theorem we need to apply two sections. Okay, so by summing of two moment of inertias we will be getting the moment of inertia of the whole composite section. So for figure 1 I need to apply this equation. So for getting the moment of inertia which is here with respect to KK axis, we need to find out Ig1, which is the moment of inertia with respect to center of gravity of first rectangle, and A1, which is the area of first rectangle, and H1 is the uh, pa parallel distance or perpendicular distance between the parallel axis and the center of gravity of the section or figure we are going to consider. So first we need to find out Ig1, which is the moment of inertia with respect to center of gravity of the first rectangle. So already we know the moment of inertia of the rectangle with respect to its center of gravity is as BDQ by 12. Okay, so B with respect to this parallel axis, which is the KK axis, the breadth will be equal to 120 mm. So 120 into, and width is equal to 40 mm. So 40 cube divided by, we can write it as 12. So when you use the calci, the value will be getting as 640 into 10 power 3 mm power 4. So which is the moment of inertia of the first rectangle with respect to the center of gravity. So remember this value. Okay, next similarly what we need to know, the area of the rectangle A1, which is the area of the first rectangle. So already we know length into breadth, or here breadth into depth we can consider. Okay, the length we can consider as a 20 and the breadth we can consider as a 40. So 120 into 40 will be getting the value as 4800 mm square, which is the area of the rectangle A1. Okay, with reference to the formula we have determined the area also. So next value we need to find out what is the perpendicular distance between this axis and the center of gravity of the first figure, which is h1 we have considered. So h1 is equal to, how can we write it, as already up to this side, up to this edge of the L shape, which is the composite section, the distance is 100. So 100 plus the distance from this edge to the center of gravity of the first figure, which will be the half of the width only. So width is given as 40, so half of the width means we need to consider 40 by 2, so which will be giving 20. So 100 plus 20 will give you 120 mm, which is the perpendicular distance between the parallel axis and the center of gravity of the first rectangle. So all the values we have determined. Next we need to go for, so this is related to first rectangle now, so consider ikk1. Similarly here we need to find out ikk1. So as per the formula, first we need to take ig1 is 640 into 10 power 3 plus what is the area, 4800, into what is the height, sorry, what is the perpendicular distance between the parallel axis and center of gravity, which is 120, which is square we need to take. So when you modify by using the calc, when you calculate the value will be getting like 69.76 into 10 power 6 mm per 4, which is the moment of inertia of the first rectangle with respect to the required axis, which is the kk axis. Okay, so related to first figure, the convenient figure is over. Next we need to go for second figure. Okay now, so second rectangle we have to go. So for second rectangle, so consider for figure 2, which is the second rectangle. Again we need to apply same parallel axis theorem ikk2, which is equal to moment of inertia with respect to center of gravity ig2 plus area of the rectangle, second rectangle a2, into perpendicular distance between the axis and the center of gravity of the second rectangle whole square we need to consider. So in this equation, again first we need to find out what is ig2, moment of inertia of the second rectangle with respect to the center of gravity, which is the same formula, bd cube by 12. Okay, with reference to the figure here, what is the b value parallel to this axis is 40 and the depth will be 240. So now go for b value is 40 into, and depth value is 240 whole cube divided by 12. So use the calc, again the value we get like 4, sorry, 46.08 into 10 power 6 mm per 4, which is the moment of inertia of the second rectangle with respect to the center of gravity. Remember this value again. Okay, so next we need to find out what is the area of the second rectangle. So the area of the second rectangle is 240 into 40. So when you multiply, automatically you will be getting the value 9600 mm square, which is the area of the second rectangle. So remember this value again. And next we need to find out which value, h2, perpendicular distance. So already we have analyzed the perpendicular distance for the first figure. Similarly we can analyze, so the distance up to this edge is 100, and from this edge the center of gravity will be exactly in the middle position. So 100 plus 240 by 2 we can write it as. So similarly here also write h2 is equal to 100 plus 240 divided by 2. So when you apply this, automatically the value will be getting 100 plus 120. Okay, then 220 mm is the perpendicular distance between the parallel axis, that is kk, and the center of gravity of the second rectangle. So with the help of these three values, what are the three values, ig2 and a2 and h2, we need to find out ikk2, which is the moment of inertia with respect to the required axis for the second rectangle. So ig2 value we got 46.08 into 10 power 6, and plus area, what is the area, 9600, into, and the height, what is the height, 220. All the values are in mm only. Okay, maintain all the values in mm or meters, that is our wish. So here I have taken all the values in mm, so take square here. So when you apply this, the value will be getting 510.72 into 10 power 6 mm per 4. Okay, this is the moment of inertia of the second rectangle with respect to the kk axis as per given in the example problem. Next, so we need to find out moment of inertia of the whole section with respect to x-axis, which should be sum of the two moment of inertias. So ikk1 plus ikk2. Okay, so go for finding ikk. So which is the moment of inertia of the composite section with respect to kk axis. So what is the value we got? Ikk1, go through the value again. So ikk1, the value we got it as 69.76 into 10 power 6. So write down here 69.76 into 10 power 6 plus. So what is the ikk2 here? It is, so go through the value here, whatever the value we have calculated, so which is plus 510.72 into 10 power 6. So when you sum these two values, you'll be getting the value as 580.48 into 10 power 6 mm per 4, which is the required moment of inertia value, which is the moment of inertia of the composite section, which is the combination of two rectangles, and the shape we got it as L shape. So with respect to the k axis is given, the value is 580.48 into 10 power 6. Okay, this is the way of calculating the moment of inertia of the composite section with respect to a parallel axis. So the first step is we need to split the composite into two convenient. According to the number of basic sections, we need to split the shape into convenient parts. Then we have to make use of the parallel axis theorem, which is IAB is equal to IG plus AH square. So this equation we need to apply each and every part we have divided or we have split. So by finding this moment of inertia with respect to the axis given for each and every figure, by summing up all those values, we'll be getting the required value, which is the moment of inertia of the whole section. So I hope you understand. If you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. Once again, thank you all.